Hi. Yeah, thank you very much. My name is Felix from Open Zeppelin. You might know our security library of smart contracts, and we of course also do audits, monitoring, and many more things. And today I want to talk to you about testing. So we have like one really crucial question to answer. If we get 100% test coverage, do we get some security, no security, a lot of security? And I'm trying to answer this today. So let's take a step back. Why are we testing at all? Typically, you want to see whether your code base actually has some kind of functionality. Probably the functionality you intended your code base to have. That's kind of the point of tests. But then, looking a bit further, you have like additional points of your tests. Typically, you don't only want to do unit tests, you want to do like some integration tests or some end-to-end testing, and they actually have a descriptive functionality. So you can really see like what's the happy path through your code base, what are like the interesting ways a potential end user can interact with your code base. So this kind of descriptive functionality is also in there. And then, does it contribute to security? Well, we are hoping that it does, but we don't know at this slide. So let's move on and answer this question later. Now, talking about the quality of tests, after a while you want to be done with testing. So we have like different quality metrics. The first one is a functional metric. It's the test coverage of your code base. And this is typically like a line coverage or a branch coverage. It's a nice number. And we're assuming that it's like 100% in our test example. So we're doing very good on this case. And then, again, descriptive means that you have kind of interesting test cases. Not just like very small unit tests, but some very interesting end-to-end test cases. And now, it's again the question, do we need an additional metric? Or are we just like accidentally already done with security and have perfect security as well? So let's look at a small example. This is like a very small ERC20 token I wrote. You can see above in the slide, 100% test coverage is ensured to us by like Foundry. And you can see in the lower part of the slide, well, I wouldn't really call it interesting, but because it's a minimal example, it's kind of like the 3 use cases I imagined for this token, that you can mint it, burn it, transfer it. Yeah, they all work out. They are all covered in this test case. So basically, we're doing perfect on the functional and descriptive side. So are we secure? No. This has a public burn vulnerability, so you can just burn any user's token. And basically, this is like a critical vulnerability, and the security here is really like 0%. You need to fix this. You can't deploy it in this shape. But so what is missing? This test case is missing. If you don't know the Foundry syntax, you see in the name that it starts with test fail. So it's kind of asking for the opposite of what you see in the test case. It kind of verifies that this test will fail. And yeah, it's a typical test that just tests that like an arbitrary address, like a non-owner address, can like burn 1,000 tokens of another user. And yeah, you really want to make sure that this cannot happen. So you want to write this kind of negative test case. Now, this was a small example. Let's move to the overall principle. What we typically see when somebody says they are doing testing is completely on the left side. They do functional testing, they are concerned with coverage. But this is just one aspect of testing. And it's good that you do it, but it has actually very little to do with security. If you want to do security testing, you have to be on the right side. And you have to ask yourself, like, how much testing of an absence of functionality am I doing? So for example, for unauthorized functions, am I really testing that like a message sender that is just an arbitrary person cannot interact with the contract in a certain way? And so this testing for absence is what we call security testing here. But now I want to take an additional step back and wonder about like how does testing look in theory and in practice. So in theory, numbers provided by IBM is that, yeah, we should invest a lot in testing because it really pays off. If you find something early during the design phase, the implementation, the dedicated testing phase, your cost is kind of moderate. and it really explodes in the deployment phase. And this is not for blockchain systems where like the number 100 you see might be even higher because of like the TVL attached to it. But this is already like across arbitrary software systems. So in theory, everybody should basically do the best possible testing because the economics clearly tell you it will pay off. Now let's look at the practice. Testing is not sexy. Testing is really like uncool. Nobody says, oh, I'm really passionate about like QA testing, I'm a tester. Like all the cool stuff is basically associated with hacking. So of course for like your protocol, that's kind of like a bad thing, right? Like you don't want to be hacked, but hacking is rather cool, while testing is kind of like the ugly thing you have to do, but no one really wants to do. So let's now look at how we can like fix that. So this is my recipe to make testing attractive. Basically, do hacking as part of testing. So to do like really good security testing, we start with while true, because you can iterate this loop forever. What you do is you come up with like a creative POC exploit. You're basically trying to exploit your own protocol you're trying to develop. Then you verify that it doesn't work, hopefully, or you actually found something that you really need to fix. And then you just don't throw this away, but you integrate this as a test case into your security testing test suite. And that from like a day-to-day activity of how you think about it makes this a lot more attractive, because this is not like the unit testing or the boring kind of testing you know, and it's like the typical university curriculum, but this is more like the modern kind of like hacking mindset you apply. You just apply it to like an artifact that makes it into your test suite. So nice theory, but now to actually add more practical points to this, let's look at the projects just this year that had like some code level vulnerability. So this is no exposure of private keys, no rug pulls or something like this. Rather, they had a bug in the code that could have in principle be prevented by this kind of testing methodology. And we see that like the funds stolen today in this year are 250 million already. So I think this is like a good argument to potentially integrate this kind of like thorough security testing into the test suite. So now on a very high level, if you are a decision maker, you don't want to like recall the details here, you want like a really simple metric, count the number of interesting test cases based on proof of concept exploits in your test suite and make this the metric of security testing. So to summarize, 100% test coverage is functional testing. It's not related to security. If you want to do security testing, which you should test the absence of something. If you want to do this in a good way, you need to like adopt a hacking mindset and really do exploit POCs as part of your test suite. And unfortunately, there's no silver bullet. This is not exhaustive. You can start this as part of your project internally, and then best reach out to your security partner to basically further enhance this kind of testing methodology. Thank you very much.